I now have set up my opposites and my adjacents, yes? Once I've set up a theta, I have my opposites and adjacents. So what is opposite to my theta? X. What is adjacent to my theta? 7. What uses opposite and adjacent? Tan of what? 60 equals opposite. What is that? Over what? How do I do that on my calculator? 7 times tan 60 will get me X. What is X? Depends on your machine. Karen. 12.1. Sounds good to me. Now, is it actually 12.1? No, it's 12.12, blah, 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 forever, yes? If I use 12.1 to find Y, will I get the best possible answer? No, why not? Because it's not as exact as it could be. But when I use my calculator to do 7 tan 60, and I get my 12.124, I know I can write it down right there, yes? But what am I going to do with that number, 12.1 and 7, to find Y? I've got to do Pythagoras, yes? So since I've got to square 12.1 anyway, but if I do it over here properly, I get a better answer. Is everybody with me? So I'm going to go ahead and leave that on my calculator. Now, I've been practicing a long time, so I can do this all in one shot. I need the square root, and I'm going to use a bracket, of my last answer squared, plus or minus. Plus what? 7 squared. And now I can close my brackets because it's going to do the square root of all that. And Y equals 14. Now, what would happen if I'd use 12.1? Well, square root, clear. Square root, 12.1 squared. Yep. 12.1 squared. Then what? Plus 7 squared. 13.9789. Everybody with me? Yep. Is either one of those, for me, marking, going to affect you being graded? No, I don't care. Everybody with me? If we were sending the rocket ship to Pluto, which is the better answer? 14. Because we use the whole number there, right? Now, some of you will say, well, Mr. Myers, you're only off by 3/100ths, which is no big deal on planet Earth, yes? But if you're sending a rocket ship to Pluto, if you're off by 3/100ths here, how far are you off by the time you get to Pluto? A long way. You miss. Everybody cool? Yeah. All right. And next color? Orange it is. Do I have a theta? What is it? 80. Once I have theta set up, do I now know my opposites and adjacents? Yes. What is my opposite? The opposite is 10. What is my adjacent? X. Tan 80 equals opposite 10 over X. What do I do? Divide. 10 divided by tan 80 equals X. And what does X equal? Whatever it equals. It's a pain for me to use that calculator and show you guys. So people should now be comfortable enough that I don't need to actually show you, do I? No. Everyone's cool with that? All right. So what is it? 1.76. Or 1.8, anything like that, right? Now, does that make sense? It should make sense, because if this is 80 and this is 90, this is only 10 degrees, isn't it? So this only moved up a very little bit. So it should be a very small number. Everybody cool? All right. Turn over to page 56, please. Angles in the real world. Because all these triangles we're drawing are not in the real world, are they? No. They're just triangles on a piece of paper, yes? Yeah. Okay. So angles in the real world. Let us begin. Everybody draw an eye. It doesn't have to be a pretty eye. It just has to be an eye. Everybody cool? All right. Now, if your eye is not looking at anything, it is just looking away from you, draw a line along where the eye's line of sight would be. It would be straight along here, yes? Everyone agree? You're all looking up because this thing is above you. But if there wasn't anything in front of you, you were just sitting, you'd be looking straight ahead. I'm looking right down the line to Micah, Adrian, and Izzy. Everyone agrees? All right. Now, let's pretend that I'm outside and I hear a plane. Now, all of you, if you're like me, still look up when a plane flies over, don't you? Don't say you don't. Even if it's a stupid little Cessna, you look up because you're like, damn, I wish I was on that plane. You all do it. It's okay. I still do it, and I'm 43. Sometimes the plane's towing a message. You're like, yeah, it's towing a message. And then you look at it, and then the message is backwards because it's on the wrong side. And then you're like, damn. Then you have to watch it till it turns around, even though you can all read backwards. Everybody does this, yes? So I hear the plane. What do I do with my eye?
You look up.
My eye looks up. And I'm going to use a green line to look up. Now, what have I just created? An angle. An angle between where my eye started and where it went up to. This is what we call an angle of inclination, or an angle of elevation, because we are raising our eyes upwards. Does everybody understand that? Yeah? Okay. Now, the plane flies away. Where does my eye go? Back to the red line, yes? I'm walking along the street, and all of a sudden I see on the ground a $20 bill. Where does my eye go? Down. What did I just create? Another angle. That angle is what we call an angle of declination, or an angle of depression. Not because you're sad, but because you are looking down. Does everyone understand? Yep. If you look up, you create an angle of inclination. If you look down, you create an angle of declination. But there is a problem with this.
What's the problem?
I'm about to tell you what the problem is. On the plane, pretend that's a window on the plane. There's me.
Looking down at yourself.
Right? I look down and see Javon looking up. Where is my line of sight? Before I see Javon, where is my line of sight? No.
Oh.
My line of sight. Before I see Javon, where is my line of sight? It's straight out this way, yes?
Yeah.
I should have done this at a little lower angle. So I'm going to make that... my line of sight is out here, yes? When I look down at Javon, what do I make?
Angle
an angle of depression. Where is it?
The pink and
It's between the pink and the green. This is Meyer's angle of depression. What is this green? This is Javon's what?
angle of elevation.
Angle of elevation. What do you know about those two angles? They're the same. Right? Because as far up as his eyes go, mine go down. Because it creates this rectangle, doesn't it? Up, down. Those two are the same. All right? Now, the mistake all of you are going to make when you're doing trig in the real world, well, when you're doing trig questions that deal with real world things, if I ask you where is my angle of depression, you're going to put it here. Even though I'm doing this lesson, some of you are going to put it there. Don't be that kid. Everybody understand? Angle of depression and angle of elevation are between the horizontal and up or the horizontal and down. This is not between the horizontal and down, is it? Everybody cool? All right. That's the first part of angles in the real world. There's another part of angles in the real world, which is why you have so much blank space down here. When else in real life do we talk about things in degrees? Micah?
Temperature.
Temperature. Anywhere else? Pardon me? Burns. Oh, third degree burns. Okay. Yeah. When else? I'm looking for one that would have a mathematical directions. We talk about directions, right? You've all played Call of Duty. He's on a heading of 312 degrees. Or you've seen it in a movie, right? Okay. How does that work? This is how it works. It works in two ways, so it can be a little bit confusing. The first way it works is the way you're comfortable with. This is a compass, yes? What do we put traditionally at the top of a compass? North. What is to the right? East. Never eat soggy wieners. Northeast, southwest, yes? Okay. When we are counting directions this way, north is considered 360 degrees. Some people say it's 0. It doesn't matter because it's a circle, right? When we are counting directions this way, we go clockwise. What is E? 90 degrees. What is S? 180 degrees. What is west? 270 degrees. All right? Everybody with me? So if I tell you, and I'm going to do this first one pink, if I tell you I am walking at a heading, or it might be bearing. I can't remember which is which. I'm sorry. I'll look it up in a second. But I'm going to say if I am walking at a heading of 47 degrees. I am starting right here. You always start in the middle. Where am I walking?
You're walking northeast.
Northeast, yes? Not quite exactly northeast, because northeast would be 45 degrees. Everybody with me?
Yep.
So I would be walking over here. Is everyone cool?
Yep.
All right. What if I told you I was walking at a heading of 112 degrees? Where would that be?
Southeast.
Southeast.
Down this way, yes? Would it be halfway? No, a little less than halfway, yes? Is everybody cool with that?
Yep.
Does everybody understand? Okay, now, you take a guess at what my heading is if I were walking this way. What is that heading?
270
Okay, 260 is cool. The reason I'm happy with 260 is because you recognize straight west would be 270, so it's got to be a little less. Everyone can do this, yes?
Yeah.
Okay, now, what is missing from the pink, the green, or the gray line that doesn't, or that prevents us from doing trigonometry? What do I need to do trig? I need what? I need another leg. I need a 90-degree triangle, don't I? Do I have one?
No.
Can I make one?
Yes.
Could I make this 90-degree triangle? Oops, I want to use pink.
Yes.
Could I make this 90-degree triangle?
Yes.
If I made those two 90-degree triangles, where is the 47? Is it X or Y? X. This is 47, which makes automatically what is Y? No. 43. Because the whole thing is 90, and I've used 47 to get to there. Does everybody understand? Okay. What then, if I needed to do trig in this section, it would be this or this, yes? Okay. What then is X? 22. Why is X 22? X is 112. This is 112 degrees. So why is it only 22 if I want to do trig with it? Because it's 22 from 90. Everybody with me? What then is this side of it? 68. Does everybody understand? Okay. What then is this triangle? What is this guy and what is this guy? 80 is which one? Bottom or top? Bottom. And what's the top? 10. Is everybody cool with that?
Could you explain it maybe one more time in an example, please?
Okay. That's why I leave one quadrant empty. That yellow line is a heading of 310 degrees. Which means I've started at 0 and gone all the way around to 310. I can't do trig unless I make a triangle. Yes? So, there's my triangles, yes? So I have an angle here. Now, it's 310. How far is this green line? It says right there.
70 seconds.
Okay, and this is 310. So how far is this? No, you guys can't say it. I know you all know it. This is for him.
40.
Why?
Because it's in between the 370 and
How do you know it's 40 past 270?
because I did some
You did subtraction. That's 40. So what does that make this side?
Is that 360 or 0?
Doesn't matter. This distance from west to north is 90 degrees. If this is 40, what's this? 40 and 40 is 90?
50.
50. That's how you do it. Does everybody understand? Now, I apologize that I can't remember if this is a heading or a bearing. I'll look it up. The other one is what I'm about to show you over here. Okay? So this is either a heading or a bearing. I can't remember which it is. Now, let's come over to this side and let's do another one. The other one, and this is the other thing we do. This one is based on degrees. This one is based on direction. Okay? Now, direction, and I don't remember again if it's a heading or a bearing, is always written like this. It is written as a direction, then a degree, and then another direction. Okay? This is the main direction, or where you start from. This is your adjustment. and this is your distance. So here is what I mean, because it's hard to show without an example. North 22 east. What direction is north? Straight up, yes? So if I was making no adjustments, I would be walking straight this way, yes? But I am making an adjustment. How far am I adjusting? 22 degrees. In what direction? East. Where is east? To the right. So I am actually moving north, but 22 degrees to the east. Does everybody understand? So if this is 22, if I want to do trig, what's this one? $68. Is everybody cool? Okay, let's try to do another one. I am starting south, but I am adjusting 38 degrees east. Where would straight south be? Down. And I adjust in what direction? If I'm walking straight south, am I turning to the left or the right? Left. But as we've drawn it here, on our paper, it's to the right. In the real world, it's to the left. Everybody understand that? So my line would go down here, yes? Where would the 38 be? On the left or the right of that line? Left, because the adjustment was 38 to the east. If I want to do trig, what is this side? 52. Is everybody good? Yeah? Okay. Well, now you're going to try 2 on your own. I'll do a red one. No, I've already done a red one. I'll do a pink one. I am walking west, west 45 south. Where's the line? Josh. It's right in the middle. It's directly southwest, isn't it? This is 45. This is 45. Everybody good? Okay. So please notice that south 38 east is the exact same as east 52 south. Does everybody see that? So what is this pink one the same as? South 45 west. And what is this red one the same as? East 68 north. Everybody cool? Yeah? Okay. I'm going to find out which of those is bearing and which of those is heading while you're doing your work, because I can't remember which is which. And usually when I can't remember something like this, when I do a bunch of other stuff, it pops into my head, but it hasn't popped into my head. Why? Because I'm old. So you people are going to do page 76. Now, this is the first textbook page I've given you. Please notice I have supplied the answers. If you're doing this properly, you should cover them up and do all the work first. Okay? Well, page 76 was the page that it was in the textbook. Back in the day when I actually still used a textbook and I had this outline, I had page 76 because that was the page from the textbook we were doing. But I don't like you guys carrying around textbooks, and textbooks cost $60 each, and kids lose them all the time. Actually, they're more like $100 each. You guys write in them, and just, not you, of course, you're classy, but kids ruin textbooks, right? So, since you're going to write in it anyway, I just made this so you could write in it. So you are going to work on this page. You have class for something like 10 or 15 more minutes. That's a lot of time considering it's only 1, 2, 3, 4, 5, 6, 7, 8 trig questions. Some of them you're not going to be able to do because they require thinking about trig, and we haven't practiced it enough. Is that okay? Of course it is, because this is practice. When I go over it, you'll pay attention and you'll sort yourself out, right? Go.